Hi, we're Team Argonne and we research emission control in the beer brewing industry, specifically at the Tampa Yuengling Brewery. D.G. Yuengling & Sons is America's oldest brewery, originally known as Eagle Brewery, but later renamed after their founder David Yuengling. They now use an eagle symbol for their logo. They produce many popular beers such as Yuengling Lager, Black and Tan, Porter, and many others. It is a family-owned and operated brewery originating in 1829 and is currently the largest American-owned brewery, producing 2.8 million barrels of beer annually. They currently have two breweries, their headquarters in Pottsville, Pennsylvania, and the one in Tampa, Florida. In both breweries, they use several different air pollution control techniques in order to filter and dispose of any pollutants formed in the brewing process. The brewing cycle begins when the proper amount of corn grits and malted barley are removed from the storage bins and transferred to the hoppers. The malted barley is conveyed to the malt mill, where it is milled to the desired size. The corn grits and part of the malt are combined with water in the grits cooker to be softened and liquefied. The rest of the malt is combined with water in the mash tun. The cooker mash is added to the mash tun, and the mashing cycle is complete. The mixture is then transferred to the lauter turn where the liquid, wort, is separated from the grains. The wort is transferred to the kettle. Here the wort is boiled for sterilization and the hops are added. It is the bitter edge of the hops that balances the sweetness of the malted barley. The boiled wort is then pumped to the hot wort tank and then cooled. The wort is then transferred to the fermentation cellar. As the wort is being transferred to the fermentation cellar, pure cultured Yuengling yeast is added from the yeast storage vessels, so the fermentation cycle can begin. It is here that the yeast will convert simple sugars to alcohol and carbon dioxide while imparting its own special flavors to the beer. Once the wort is fermented, it is now called beer. The yeast is reclaimed and used for the next generation of brews. The carbon dioxide is reclaimed, purified, and later injected back into the beer. The resulting beer is then pumped through a centrifuge to increase clarity and cooled to 32 degrees Fahrenheit before being transferred to the aging cellar. The beer is allowed to age for 14 days to increase the clarity and allow flavor development of the beer. The mature beer is then cooled again and filtered for sparkling clarity, and the carbon dioxide adjusted to ensure superior flavor and foaming qualities before the beer is moved to the finishing tanks. Throughout this process, the beer is carefully monitored by the brewmaster and his quality staff. The beer is then pumped to the bottle line, can line, or kegged for distribution.
The Yuengling Brewery in Tampa operates under an operating permit issued by the Environmental Protection Commission of Hillsborough County. The emission potential of the facility is too small to operate under a Title V permit. The operating permit regulates air emissions by outlining the machinery allowed on the facility, size and quantity of the machinery, grain handling capacity of the brewery, and outlines requirements for record keeping and testing. The major air pollutants in the Tampa brewery are particulate emissions and volatile organic compounds. The main source of PM emissions is grain handling, and the permit limits PM emissions at 2.2 tons per year. Their largest source of VOC emissions is the packaging process, and the operating permit limits the potential to emit a VOC at 49.5 tons per year. Additionally, the permit does not allow odors to be emitted from the facility. In order to demonstrate compliance with the operating permit, the staff at the facility must maintain detailed records of operation that include barrels of fermented throughput, barrels of finished product, and tons of grain used. PM visual testing needs to be conducted once per year when the facility is operating at capacity. Yuengling has to notify the Environmental Protection Commission of Hillsborough County if there are any changes to its process because it may require a modification of the permit. Yuengling must complete an annual operating report to be submitted to the Florida Department of Environmental Protection, in which emissions from each process are calculated. Shown is a snapshot of this report where we can see how VOC emissions from the sterilized bottle filling line were calculated. Here we see how PM10 emissions from grain handling were calculated.
Particulate emissions from the brewing process are mainly associated with grain handling activities. Grain is delivered to the plant by rail car and unloaded via conveyor systems, then stored in indoor silos, from which it is gravity fed into the cookers. Grain is also occasionally transferred to a mill where it is ground into finer particles required for different brewing recipes. The emissions of PM10 for each of these processes is closely monitored and recorded. The grinding and unloading processes are estimated to each emit about 0.1 tons of particulate matter per year. Control of these particulate emissions is achieved through the use of 4 fabric filter baghouses manufactured by Bühler Group. The 2 baghouses shown on the left are rated for 980 standard cubic feet per minute and control emissions from the indoor storage silos. 2 other baghouses not shown capture grain dust from the unloading and grinding processes. The brewery's air permit regulations for grain handling limit the total PM emissions to less than 0.02 grains per dry standard cubic feet of air per baghouse, and limit the maximum unloading rate to 25 tons per hour. Each baghouse is subject to opacity regulations issued by Hillsborough County. A 5% opacity limit is enforced and must be verified by performing a visual emissions observation in accordance with EPA Method 9. Combustion emissions from the facility are due to the 4 natural gas boilers located beneath the mash cookers. These boilers combust natural gas fuel to produce steam needed for the grain cooking process. The combustion reaction produces nitrous oxides, carbon monoxide, and hydrocarbons as byproducts. Yuengling utilizes a lean combustion technique as a best practice to limit the formation of these pollutants. Rule 62-10 of the Federal Administrative Code exempts these boilers from any permitting and monitoring requirements due to their small heat capacity. The rule states that boilers with a capacity of less than 100 million BTUs per hour are exempt from permitting. The largest of the 4 boilers on site at Yuengling has a capacity of about 2 million BTUs per hour and thus is exempt. One requirement the facility must still adhere to is the 40 CFR 60 mandate for daily tracking of boiler fuel use. This is done by an automated system and the information is stored in the plant's control room for reference.
Yuengling uses a CO2 control system in order to reuse the CO2 in the bottling process. CO2 is captured from the fermentation process, sent to blowers, which then send it to a dry bed to dry the wetted CO2 gas. This is then sent to a scrubber to clean the dirty gas, then to a compressor, which compresses it into a liquid form. The liquid CO2 is then refrigerated and sent to a storage container where it is then injected into bottles before the capping process. NOx production is managed by temperature control. Yuengling uses low temperature burners to make sure that the NOx production is well below regulations. They also watch to see how much is being produced at one time to make sure that it is under the regulations as well. There are no treatment mechanisms in the facility to decrease the amount of NOx pollution. As you can see, even Nicolas Cage thinks that this is a great idea. VOCs are another main concern for the Yuengling factory. They are produced from packaging of beer. They are emitted through different boiling systems of the plant as well as fermentation processes. The amount of VOCs are controlled throughout the brewing processes by limiting the production of beer product. As you'll see in a little bit, these are the different sources of VOCs and the different rates in which they are being produced. These are the different sources of VOCs. They're measured in annual processes or fuel use rates. This is in tons per year, as well as summer season daily emissions, which is in pounds per day. Now we put up the summer season daily emissions because this is the most VOCs that are going to be produced in the year, because everybody wants beer during the summer. It's the most popular time, and let's just face it, drinking beer in the winter is just miserable. You want a nice hot day to be drinking one of these bad boys. So we can look at the can filling line, the bottle filling line, and the can crushers produce the most VOCs in this portion of time throughout the year as well as during the summer. And other cookers produce minimal, at best, VOCs. So they make sure to watch that to make sure they don't go over any regulations and produce too much.
As previously mentioned, some of the main pollutants emitted in the brewing process include volatile organic compounds, particulate matter, NOx, and carbon dioxide. These can all have negative health and environmental effects if not regulated or controlled. VOCs, such as ethanol, aldehydes, and ethyl acetate, are some pollutants emitted in the production of malt beverages. Although the health effects depend on the type of compound, in general, short-term exposure can cause eye and respiratory irritation, fatigue, allergic skin reactions, and many more. Long-term effects can be more severe, including damage to the liver, kidneys, and the central nervous system, as well as cancer. Particulate matter is emitted from grain malting, spent grain drying, and several other brewing operations. The main health concern regarding particulate matter is that due to the particle's small size, they can travel into a person's respiratory system and even circulatory system. This can decrease lung function, aggravate asthma, and cause heart attacks. Aside from the effects that these pollutants have on people, they can also impact the environment. Particulate matter is known for reducing visibility, causing damage due to acid rain, and causing changes in the nutrient balance of coastal waters. NOx is another pollutant of concern because it reacts with VOCs to produce ground-level ozone. It reacts with sulfur dioxide to produce acid rain, and can react with other compounds to produce particulate matter. Ground-level ozone can irritate the respiratory system and over a long period of time can cause permanent damage to the lungs. It is also a hazard to animals and crops. Similarly, acid rain can damage crops and trees as well as degrade buildings and sculptures. Carbon dioxide and nitrous oxide are both greenhouse gases. Their accumulation in the atmosphere, along with other greenhouse gases, causes a rise in the Earth's temperature. Some effects of global warming include rising of the sea levels, more severe storms such as hurricanes, floods and droughts can become more common, and ecosystems can change greatly.